Hi everyone. We mentioned before that we can calculate the three-phase power by either using the formula that the power P is equal to 3 V phase I phase cosine theta, or P is equal to root 3 V line I line cosine theta. So these two formulas can be used to calculate the power based on what input I have. I can use either this formula or the other formula. The question is how we can measure this power in three-phase system. And basically we have two main methods. One is called the 3 Wattmeter method, and the second one is called the 2 Wattmeter method. So let's see how we can connect the watt meters and how we can relate these two formulas of power to the different connections. And then we'll do some simulations to simulate that using the automation studio. So let's start with 3 Wattmeter method. So we know now that the power P is equal to 3 times V phase I phase cosine theta. So basically here we are saying that the power that we have is the summation of the power of each phase. And in this simulation and in this lecture, we'll assume only balanced system. So if I can measure the power and measure the current, measure the power in each phase and add them together, then I will have the three-phase power. And basically we use the wattmeter. We mentioned the wattmeter before, and the wattmeter is nothing but a device that has two coils, one for the current and one for the voltage. So that is the coil for the current, and this is the coil of the voltage. We connect the current coil in series, and we connect the voltage coil in parallel with the voltage of interest. So if I can and connect the 3 wattmeters like this, so the first one is I measure the current of phase A, IA, and it measures the voltage between A and the neutral. So this is basically VAN or V phase. So I measure, and this is because this is a Y connection, so that is also the phase current. Now, when you go to the second wattmeter, we will have here IB and the voltage between B and the neutral. So again, the phase voltage. Finally, C is, we'll have here IC, the current coil will measure the current in the C phase, and the voltage is between point C and the neutral. So we are measuring the phase voltages and the phase currents, and this is only applied if we have a Y connection with a neutral. And we are using 3 watt meters. What if I don't have access to the neutral? Or what if I am measuring a delta connection, so I have only access to the line current, not the phase current? With this, we use the 2 wattmeter method. In the 2 wattmeter methods, one way is to connect the only 2 wattmeters. Now there is no access to the neutral. So I measure here the voltage. So W1 basically, it measures the voltage between line A and line B. Wattmeter 2 measures the voltage between line C and line B. So I measure the VCB. And I measure the current in phase A. I measure the current in phase C. So I will prove to you now, if I calculate W1 plus W2, this will be equal to P equal to root 3 V line I line cosine theta. Before that, let's go to some basics and let's talk about the phasor diagrams. So now I have 3 phases. So I have phase VAN, VBN, and VCN. Now I will have the current. Now since I will have inductive load, the current will be lagging. So this will be my IA, and the angle is theta, the power factor angle. Now for VCN, I will have also the current here, my IC, and my C will have the angle of theta. Okay, now we want to have VAB, we know it is nothing but VAN minus VBN. So if we find minus VBN, so this is minus VBN. Now, if I add the total together here, you will get my VAB, and my VAB will be 30 degree, as we know it. VAB is equal to root 3 VAN and plus 30. Now, let's find VCB. Now, VCB will equal to VCN minus VBN. Okay, so this is minus VBN. So we will have adding these two together, and this will be my VCB. Now, my VCB will have a plus 30 degree. So the angle from VCB to VCN is basically 30 degree. Now, let's find the power. The power of W1 is basically, it is the voltage VAB and the current IA. So this will be equal to VAB times IA cosine theta of VAB minus theta of IA. Now, what is this angle between VAB and IA? The angle is 30 plus theta. As you can see it clearly here, it is 30 plus theta. This is the angle between VAB and IA. Okay, so this will equal to VAB times IA cosine of theta, or 30 plus theta. Now, if you go to W2, which is basically VCB times IC cosine of theta VCB minus theta of IC, or the angle between VCB and IC. So this is equal to VCB IC cosine. Now, when you look here, what is this angle between VCB and IC? It is 30 minus theta. It's 30 minus theta. Now, we have a balanced system. So VAB and VCB are equal magnitude. IA and IC are equal magnitude. So this is will equal to V line, I line, cosine of 30 plus theta. And this will equal to V line, I line, cosine 30 minus theta. Now, we want to find W1 plus W2. So W1 plus W2 is equal to V line, I line, cosine of 30 plus theta plus V line, I line, cosine of 30 minus theta. Okay, so I will take now W1 plus W2. I will take V line, I line as a common factor. We'll have cosine of 30 plus theta plus cosine of 30 minus theta. Let's find this term alone. Okay, so cosine 30 plus theta, we just use the known trigonometric identities. So this will equal to cosine of 30 cosine of theta minus sine of 30 sine of theta. Cosine of 30 minus theta will equal to cosine 30 cosine theta plus sine 30 sine of theta. Now this will cancel, and when you add these two terms, we will have, when we add cosine 30 plus theta plus cosine 30 minus theta will equal to 2 cosine of 30 cosine of theta. Now, cosine 30 is root 3 over 2. This is equal to 2 times root 3 over 2 cosine theta. This will cancel, so this is equal to root 3 cosine theta. Now, so all of this will substitute with this, so we will have W1 plus W2 is equal to root 3 V line I line cosine theta, which is the three-phase power. Now, let's go now to Automation Studio. I did some small system. Let's see the simulation of that system. Okay, so we'll go here. Now, that is my system. Let me zoom a little bit on it here to give you more insight. Okay, so basically I connect 3 watt meters and 2 watt meters. So this is the load. It's 500 volt amp load with 0.8 power factor lagging. So the P, the power, total power is around 400 watt. It is 400 watt. Okay, so we'll measure around this figure because of the losses in the system. So now if you look here, let me again zoom a little bit more here, and let me look to the 3 watt meter. So I connect 1, 2, 3 watt meters, each one between a phase and a neutral. So for example, this, the first one is between phase 1 or phase A and the neutral. So the current coil is in series with the with phase A, and the voltage coil is between phase A and the neutral. You go to the second phase or phase, here it is UVW. I mean, these are just numbering. In Europe, they use UVW, or so we use it here ABC or 1, 2, 3. So there are different naming of the phase, or red, yellow, blue. So there are different names. So U is phase A basically. So here we go to phase V or phase B. Again, I'm measuring the voltage between phase V. So this is the coil connection to phase V or B, and then the second part of the coil connected to the neutral. So the neutral is connected, and this is for phase C. So that is the 3 watt meter method. Now for the 2 watt meter, we connect everything line to line. We don't use the neutral. Here in the 2 watt meter methods, we don't use the neutral. So between phase A and B and C and B, as I have shown before. So here, for example, in the second watt meter, I connect phase C, the first part of the coil, and the second part of the voltage coil is phase B. Okay, so now let me zoom a little bit out here and let me run the simulation. So we will have here the power. It is, as I said, it's around 400 watt, because now of the losses, there will be a little bit of discrepancies. So here we have phase A, B, and C. If you add the 3 of them, you will get around 395 or 96. And again, here, if you add these 2 for the 2 watt meter method, it is also around the same figure. So clearly here, both of them will give me the result. Now, which one is better? Obviously, the 2 watt meter is better for 2 main reasons. The first one is less expensive because I'm using only 2 devices, 2 watt meters instead of 3. Second, usually or in many cases, I don't have access to the neutral. And whenever I don't have access to the neutral, I cannot use the 3 watt meter method because I have to access the neutral. This is why this is the preferable method. And most of the time we use the 2 watt meter method.